Centroid and moment of inertia. Centroid concept is used only for moment calculations. Okay. Center of mass. It is defined for solid bodies. Thickness is equal to thickness not equal to 0. It is point where all mass of body is assumed to be concentrated. Center of gravity COG. It is a point where all the weight of the body is assumed to be concentrated. COM, and COG will be identical if body is placed in uniform gravitational field. Centroid. It is defined for plane bodies, thickness equal to 0. It is point where all the area of body is assumed to be concentrated. Note: in some analysis is done on basis of cross section and it is plane geometry, therefore only centroid is used. How to locate centroid? Centroid will always lie on axis about which body is symmetric, because where all area of body is assumed to be concentrated, so which is symmetric is always lies on axis about which body is symmetric. For example, for triangle this is symmetric, for a semicircle this is symmetric, for a square these two are a rectangle these two are symmetric. Integration method. Integral x dA is equal to ax bar. Integral ax dA is first moment of inertia, total of moments. Moment of total x bar is equal to integral x dA by a. Y bar is equal to integral y dA by a. Y dA by a. M fix is equal to integral 0 to L x w dx. M fixed is equal to WL square by 2. Here M fixed is equal to WL square by 2. Another example, this line is x plus y is equal to 5. X bar is equal to integral x 0 to 5 x dx into 5 minus x dx by half into area. This whole part is to be considered. Integral x dA is equal to y dx. This let's consider small point at a distance x from origin. dA is equal to y dx is equal to 5 minus x into dx. So integral 0 to 5 dA by total area half into 5 into 5. X bar is equal to 5 by 3, y bar is equal to 5 by 3, as it is symmetric. X plus y is equal to 5. The first moment of area of a body about an axis which is passing from centroid must be 0. If the first moment of area of a body about an axis is 0, then that axis must pass through centroid of the body. X bar is for an arc part of circle of radius r, which includes angle of 2 alpha on each side. The x bar is equal to integral x dA is equal to minus alpha to plus alpha about this axis of symmetry. 2r by 3 into x axis 2r by 3 2r by 3 cos theta. This can be considered a small triangle, very small element is considered as triangle. So 2r by 3 from top, x is 2r by 3 cos theta, theta is this angle, we consider d theta the small element. Okay, area of that small element is half into r d theta by alpha r square is total angle and total area is total area. For full circle it is pi r square, so for this 2 alpha it is alpha r square. X bar is equal to 2r sin alpha by 3 alpha. Y bar is equal to 0 symmetric about y axis. Y bar is equal to 0. Now like it will be here. Okay, biparts method used for ITCL shapes. X bar is equal to sigma A xi bar by sigma A y bar is equal to sigma A yi bar by sigma A. Find central distance of base of I section. From the base of I section, y bar is equal to a1 y1 bar plus a2 y2 bar plus a3 y3 bar by a1 plus a2 plus a3. Like from this base, central this distance y2 bar, this is y1 bar, here it will be y3 bar. Based on areas, we can calculate it will be 78. Okay. Find out distance of centroid from the center of bigger circle. Symmetric about x-axis. Symmetric about x-axis. Y bar is equal to 0. Symmetric about x-axis. Y bar is equal to 0. It is removed. So a1 x1 bar minus a2 x2 bar by a1 minus a2. a1 is pi r square, x1 bar is 0, 0, a2 is pi r square by 4, x2 bar is from this 0 comma 0 distance r by 2. So from that we will get x bar is equal to minus r by 6. The meaning of minus is from here in this direction r by 6 centroid will be located. Moment of inertia. Moment of inertia is the mass of per world of rotation. Mass in linear moment is equal to MOI, moment of inertia, and angular moment. Both mass and MOI represent resistance against change in position. MOI is used in bending moment and torsional moment. MOI is second moment of area or mass. First moment is centroid. Okay, area MOI IY is equal to integral A x square dA. IY about y axis is x square dA integral. MOI indicates the distribution of particles about reference axis. I1 here about this axis particles are far away then when compared to if axis is like this, so I1 is greater than I2. MOI is a non-zero positive quantity. Find out moment of inertia of given rectangle about horizontal centroidal axis. If we consider like this, Ix is equal to integral y square dA. Y square dA. dA is b dy. Then after solving from limits from d minus d by 2 to plus d by 2 y cube by 3, then b by 3 d cube by 8 minus 1 minus d cube by 8, then ix is equal to bd cube by 12. So from centroidal axis ix is equal to bd cube by 12. D will be divided. Parallel axis theorem. It is used to transfer the moment of inertia above from centroid axis to any other parallel axis. Ix1 is equal to integral a y plus k whole square dA. Ix1 is equal to ixc plus k square integral dA so square. So this is the proof actually. If it is at a distance, Ix1 is equal to integral a y plus k whole square dA, and this will be 0. Y dA will be 0 about as it is about centroid. Ix1 is equal to ixc plus iak square. Ixc plus iak square. Ix1 is equal to given if ix2 is equal to question mark. Ix1 is equal to ixc plus ak square. Ixc is equal to ix1 minus ak1 square. X2 minus xc. Ix2 is equal to ixc plus ak2 square. Ix1 minus ak1 square plus ak2 square. Ix2 is equal to ix1 plus a into k2 square minus k1 square. Like these two are not centroids, then ix1 ix2 is equal to x1 plus a k2 square minus k1 square. K2 k1 are both from centroid, the centroidal axis. Find out moment of inertia of I section about the horizontal centroidal axis. Horizontal centroidal axis is this: Ix is equal to Ix1 plus A R square, A area of this A into R square. It's from here to here, ASL square into 2 plus I2, this second section. From that we will get 1.717 into 10 power 8 mm per 4. Or else in another method we can calculate by considering whole rectangle IXC, then minus out these two rectangles I moment of inertia, we can get the same answer, 1.717 into 10 power 8 mm power 4. From workbook, some questions related to it which can be easily calculated by using above concepts itself. Here hole is there, then we have to subtract. Here also same. For semicircle IYC, IXC is like this, IYC will be like this. IYC is equal to 0.11 R power 4, IX is equal to 0.393 R power 4. For circle, Ix is equal to pi by 64 d power 4. This is important because we will use many circular shafts where this formula will be used. Ix is equal to pi by 64 d power 4. Another question. Okay, some important moment of inertia. Rectangle. About this axis, BD cube by 12. About this axis, DB cube by 12. Square A power 4 by 12, A power 4 by 12, about any passing through planes. The triangle BD cube by 36, about this centroidal axis IX is equal to BD cube by 36. Circle IX is equal to IX is equal to pi by 64 d power 4. Perpendicular axis theorem. This theorem is used to find out the moment of inertia about an axis which is perpendicular to the cross-sectional area. Iy is equal to integral a x square dA. Ix is equal to integral a y square dA. Iz is equal to integral rho square dA is equal to integral y square plus x square dA is equal to integral a y square dA plus integral a x square dA. Iz is equal to ix plus iy. Iz is represented by j, which is polar moment of inertia. For circle, Ix is equal to Iy is equal to pi by 64 d power 4. Izc is equal to j is equal to Ixc plus Iyc is equal to pi by 32 d power 4. J is equal to pi by 32 d power 4. J is equal to Ixc plus Ixc plus Iyc. Similarly, another two perpendicular, also it will be same. Ix plus Iy is equal to Ix dash plus Iy dash. At a point, the summation of moment of inertia about any two mutually perpendicular set of axes remains constant. Use of moment of inertia. In bending and twisting moment, equal equations which we have to write down the moment of inertia about an axis about which the moment is applied. For example, if moment is applied about my by iy, m if it is applied by xi, my x by ix, if it is about z axis, tz by iz